Raise some.
Cain. You gotta raise some Cain. In the heartland where the faith runs strong, we've seen the shadows growing long. Watch those around us be deceived. Yeah, the fight is at our doors, no matter who we believe. Corruption, lawless day and night, we'll speak the truth into the light. We'll bring the battle, heed the call, watch the whole thing fall. We gotta raise some Cain, show the lies, break some chains and make things right. Feel the power, be the change, time is now. We gotta raise some Cain.
Hey, Patriots, it's another edition of the Raising Cain Show, and boy, do we have an exciting one tonight. Look, folks, I talk about a lot of things, including politics, and we get into geopolitics, all of that, but tonight we have a special guest, and we're going to talk about science. We're going to talk about specifically about astrophysics and about the things that are going on in our universe and in our solar system. It's going to be a very interesting conversation. With us, we have a very great guest. But before we get into that, of course, I'm going to run the commercial break so we get that out of the way. And then as soon as we come back, we're going to have a great time talking and getting into this great subject. So, folks, stick with us, and we will be right back after a short commercial break.
Heard of Q Broadcast? It's taking the world by storm. People are cutting the cord to their high cable bills and moving away from streaming services like Netflix, Hulu, and others for something better. Q Broadcast. For just $60 a month, you'll get access to every channel you could ever want, including HBO, Cinemax, and Stars. And the best part? There are no contracts, no hidden fees, and you're free to cancel anytime. With Q Broadcast, you can enjoy streaming live TV, movies, and top series on up to 5 devices at once. Whether you're at home or on the go, Q Broadcast makes sure your entertainment is always at your fingertips. Imagine being able to watch all your favorite channels from anywhere, anytime, without any restrictions. We're talking about thousands of movies, hundreds of TV series, and a huge library of live channels, all in one place. And don't forget video on demand and pay-per-view events. Those are included at no extra cost, so you'll never miss a big event again. Now, take a second and think about your current cable bill. You're probably paying anywhere between $100 and $300 every month, locked into long-term contracts and hit with surprise rate increases. With Q Broadcast, that's a thing of the past. It's just $60 a month. No contracts, no extra fees, no hidden costs, and no price hikes. Why juggle multiple subscriptions like Netflix, Hulu, and cable when Q Broadcast gives you everything you need in one convenient package? People everywhere are switching to Q Broadcast, saving money and getting more content than ever before. So, what are you waiting for? Click the link in the description and sign up for Q Broadcast today. Just $60 a month, no contracts, no hidden fees. It's time to take control of your entertainment and start streaming smarter.
Welcome back, Patriots, to the Raising Cain Show. Boy, do we've got a fun discussion tonight. Look, I always get into politics, geopolitics, and different things that are going on around the world, but tonight we're going to get into what's going on in our solar system and even beyond that. Tonight's conversation is going to be about the science shaping humanity's long-term survival and expansion beyond Earth. Our guest is Dr. Avi Loeb, Harvard professor and one of the world's leading physicists. His work focuses on near-Earth objects, something many of you have probably heard about recently, and planetary defense, as well as the scientific realities of space exploration. From safeguarding Earth to preparing for human missions to Mars, please welcome Dr. Avi Loeb. Doctor, thank you so much for joining us tonight.
Thanks for having me. It's a great pleasure.
So I have typically my show gets into politics. We get into, the geopolitics going on around the world and everything. But this topic and scientific inquiry is something that's always been fascinating to me. I have one of those minds that just wants to absorb information all the time. And I love learning about, this frontier of space. And, and it's one of those areas where I still feel like our perception of it down here on Earth, it's got to be a completely different experience when you're out there. And so I really, I've been fascinated for a long time about this concept of, near Earth objects and things like that. And of course, that is an area where you are an expert in. And in the news, there has been a lot of talk over the last year about one particular object that has had some very interesting behaviors and interesting shape and things like that. So without further ado, I want to let you kind of lead the discussion on this because you're the expert. But maybe before we get into that, why don't you tell a little bit about your background and how you ended up in this field? Because I think for a lot of people, especially the people who are in my audience, many of them probably have no idea, what exactly an astrophysicist does, and what makes that different than, say, a theoretical physicist or a quantum physicist. What is specific about astrophysics?
Well, first, let me say, many people might say, we have enough trouble here on Earth. Why worry about what happens out there? And I would say, actually, it can bring us to a better place because it gives us a bigger perspective about our cosmic neighborhood. We look out with telescopes, and what we see is a huge collection of houses on our cosmic street that look just like ours. There are 100 billion stars like the sun in the Milky Way galaxy alone. That's our own local neighborhood, or you might say a town. And there are almost 1 trillion galaxies like it in the observable volume of the universe. And who knows how much more outside of where we can see. We can only see the region that light traveled since the beginning. There was a beginning, just like in the biblical version. And we know that because the universe is expanding, and it started at a very high density of matter and radiation early on. And since then, it gets rarefied as time goes on. And we can look out a certain distance, which is the distance that light traveled since that point in time, which we call the Big Bang. And already within the volume that light traveled during that time, we see 10 to the power 22 stars. That's huge. And we just have one of them close to us. We call it our lamppost. We call it the sun. And, we look for keys under the lamppost. We wake every morning and see the sun, but it will not last forever. Actually, in the Milky Way galaxy, you can think of it as a graveyard of a lot of corpses of stars like the sun that died by now. So the sun will die. And just thinking about the vast scale of space and time that we live in, the universe is 13.8 billion years old. That's roughly 100 million times longer than the oldest human that was ever alive, 100 million times longer. And the space, just within the Milky Way galaxy, you can think of it as our own neighborhood. Space is tens of thousands of light years, meaning that it takes light tens of thousands of years to cross that distance. It's huge. And we just live on a tiny rock that was left behind from the formation of the sun. Okay, this Earth that we call our home is whatever was left. It's a residue of all the material that assembled to make the sun, one of those stars. So it gives you a perspective about where we are. Now, if you just read the news every day, we are completely focused and occupied with what happens on this rock. We engage in zero-sum games. Some nation, wants a little bit of territory on this rock, and they fight for years. I'm talking about the Russia ambitions in Ukraine, But think about it in a global perspective. It's nothing. There is so much more real estate out there.
Oh yeah.
So anyway, it gives you a perspective. But my point is that it can bring us to a better place, because the fundamental question is, are we alone? Are there neighbors? Are there residents on those houses? And if they exist, they might show up at our front door, knock on the door, or they might throw a tennis ball that we find in our backyard. But at any event, will give us a sense. Now, if you think about it from a religious point of view, I had a group of theologians that came to Harvard from an organization called Christianity Today, and the person who brought them over is Tim Dalrymple, and he is now the president of the Templeton Foundation. And they asked a simple question. They said, okay, suppose we find our siblings, those members of our family of intelligent civilizations. How will it affect our religious beliefs?
Mm.
And
that is such a profound question that I have been grappling with since I was a teenager and I first became a Christian. I wasn't raised in the church, but I found my faith at a young age, about 16 years old. At a very formative station of my life, but I was fascinated by the idea that we know so little about our own Earth, let alone the universe. And one of the things that has been I've been thinking about a lot, from a biblical perspective, especially for me as a Christian in the New Testament, there is a lot of discussion in biblical prophecy about end times, and one of the things it talks about is this a massive, great deception that occurs. And I have thought oftentimes, like what would have to happen for there to be this like cataclysmic, falling away from the church and total rejection of religion. And about the only thing that comes to mind would be if UFOs landed all over the earth and aliens stepped out and said, "Hey, we're here, and we're the ones that created you," or something like that. We seeded this planet. Like that would totally destroy, I think, a lot of people's faith. And I know this is a touchy subject for a lot of people that might be watching the show tonight, but I think it's an important one that we have to discuss. I think it's important that we need to prepare ourselves for any number of inevitabilities that might happen. And I do think that question right there, I don't think the church, really, I don't think many religions at all are, especially in the world's major religions, I don't think any of them are really prepared, if something like that were to happen. I don't think they would have to have any way of even knowing how to deal with it.
I disagree with you that it would have a negative effect. I think it will have a positive effect. And what I said to the visitors that came over, and I said, I have two daughters. And when the second one was born, it didn't take away any of the love that I have to the first one.
Mm.
And thinking about God as a parent that can attend only to one sibling, to one child, is really very limiting. So, in fact, if we find other civilizations that may actually be more accomplished than we are, we should be proud. It will enhance our awe and appreciation of what the universe contains. It would be very disappointing to see all these houses on the street that are completely empty. And we can learn from another civilization and appreciate how rich the world is, and get if you are a religious person, get an even better appreciation of whoever created it. So I don't think it will take away, and they were quite happy with this answer. And I think when we approach the universe, the first message that we hear is be humble, which is in a way a religious message, because you are so small relative to the immense space and time that we can observe. And also because there might be, a more accomplished space entrepreneur than Elon Musk since the Big Bang. For us to be arrogant and say, "Oh, we might be alone. We're the smartest. That we're at the top of the food chain," is quite arrogant. And I think we should approach it with humility. The foundation, and here we get to my occupation. I'm a scientist, and the foundation of science is the humility to learn. It's not the arrogance of expertise. What you often find in academia is the arrogance of expertise. Yeah. And I'm very much against that, because the mainstream of academia was wrong so many times. And we've learned from that experience to be humble. Nobody expected quantum mechanics to be discovered. It was found about a century ago. And even Albert Einstein, the most celebrated scientist at the time, that was responsible for some of the findings of quantum mechanics, he resisted the interpretation of quantum mechanics as a new way of looking at reality. He had an argument with Niels Bohr, a Danish physicist, and Niels Bohr was correct. It's a completely different perspective on reality, and we are using our understanding of quantum mechanics to build all the gadgets that we currently use. The fact that the two of us communicate, we are not in the same room yet, and it's all based on quantum mechanics. So based on that historical example, and there are many more, we should be open-minded when we approach the universe to new knowledge, because we just know so little. And
so let me cut in real quick here, because there's something that you said that I think is important. And very rarely do I have somebody say something that kind of counters what I'm thinking, and it actually challenges me and makes me go, huh. And you said something that did challenge me, which is this notion that it would be a negative thing versus a positive thing. And I'm still not so certain about that. But I do have to say one thing that you said that I think makes perfect sense, which is that, if you had another child, you wouldn't love one less than the other. And that is an important factor, because look, even if one has no concept of extraterrestrials or aliens, right? We know that God created, at least in terms of our religious beliefs, we know that God created the angels and other beings besides us. And I've often wondered, right? If I've never, for the record, I've never had any kind of interaction or experience with UFOs or aliens or anything like that. But
the same is true about me, by the way.
But I will say, I know people who I trust, people who have no reason to lie to me, who have seen unidentified flying objects, and in some of the some very spectacular movements that are just not we're not capable of doing within our own military, at least not that I'm aware of. Things that were happening, by the way, back in 1970s, and so I find it fascinating. And I will say this much, from what I have seen, and I held a very high level clearance for almost my entire career, for about 20 years. I have seen a lot of evidence that indicates that our government really doesn't know what a lot of these things are. So despite what people, the conspiracy theory that, there's this secret bases and the government has, all of this stuff, most of what I've seen has indicated that yeah, they know these things are there, but they have no idea what these things are.
I completely agree with you. And, I've been studying this for the last few years. And it's also not the job of government to figure out what lies outside the solar system. That's my job as an astrophysicist. Government is supposed to be occupied with national security. We need to protect ourselves against adversarial nations. But if we see objects that we cannot identify, it's a matter of priority, because we want to make sure that it's not other nations trying to spy on us, for example.
Right.
And when the Director of National Intelligence delivered reports to the US Congress about objects they can't figure out, I was very intrigued. So I decided to lead the Galileo project, where we are trying in principle to help governments. So we develop observatories with also machine learning software that allows us to look for outliers, objects that are not human-made in the sky. We have 3 such observatories operating right now, one in Massachusetts, another in Pennsylvania, and a third one in Nevada. And we are planning to collect data on millions of objects in the sky within the next year. And if we see anything unusual, obviously that would be very intriguing. But even if we don't, if we find only human-made objects, then I'm happy to deliver whatever we have to the Pentagon so they can protect the nation better. But more fundamentally, there are other types of objects that are entering the solar system from outside. We call them interstellar objects.
Mm-hmm.
These are objects that we know from our telescopes moving too fast to be part of the solar system. The gravity of the sun cannot bind them, so they just move through our immediate cosmic neighborhood. And the question is whether there are rocks like we are familiar with in our solar system, or perhaps something else. Like imagine Voyager, our own spacecraft, leaving the solar system. It would take it about 50,000 years to get closer to the next star, close to us. And then it will be on its interstellar journey. And if it enters another planetary system like the solar system, there will be astronomers there that could watch it. On January 2nd, 2025, there was a near-Earth object, and it was immediately cataloged by astronomers as a near-Earth asteroid, a rock that is potentially a threat because it could impact the Earth and destroy a city if it happened to collide. And then within a day, they realized, this one actually moves along the path of the Tesla Roadster car that was launched by SpaceX in 2018. So it's not a rock. They said, we take it out of the catalog, it's a car. And the only reason we knew it's a car is because SpaceX launched it. We know what we launched. But if another civilization launched a car to interstellar space, we would never know that. It would appear as a point source of light that reflects sunlight, and initially we would think it's just a rock. So my point is about new objects entering the solar system. We should be curious whether they might be packages sent by someone on our street, and that would indicate that we should watch up also for potential threats, because when we go on a blind date, very often, it makes sense to think that you are dating a friendly person on the other side. Dating partner is friendly, but every now and then there might be a serial killer. So we will need to keep in mind the possibility of a black swan event where an object that we think is completely innocent, just like the Trojan horse to the residents of the city of Troy. It looked completely innocent, but then it turned out to be quite surprising and harmful. So I see that as a new potential threat that we should be aware of, and it was not discussed much before. And in my view, we should monitor each and every such object. And there is a new telescope in Chile that just started operations. It's funded by the National Science Foundation, by the Department of Energy, and it has a camera of 3.2 gigapixels, so 1,000 times more pixels than your cell phone camera. And it surveys the southern sky every 4 days, the entire sky in the south. And it could give us new indications of new interstellar objects every few months. So we are in a new reality where we can actually monitor, at least for half of the sky, all these visitors. And I'm saying, let's check out if any of them might be a potential threat to us. And I invented the scale they called the Loeb classification scale, where we give it a rank of 0 if it's completely natural, if it's an iceberg or a rock. However, if it looks like it's technological, the scale goes all the way up to 10. And in my view, we just need to take as much data as possible about these visitors. Just like in a blind date, you want to observe the other side before you have an opinion.
One of the things that I think about in terms of where the science has gone is you think back to the earliest astronomers, the famous ones, Galileo, and what they were using in order to identify things that were going on in our solar system. You look at where we're at today, and there's been leaps and bounds along the way, but I think we're at a stage now with AI where we are leaping forward in a very massive way. In not just obviously not just in astrophysics, but in so many different fields. But how exciting it must be to be in your field right now with the advent of AI and what it's going to be able to allow us to do, in terms of just observation and collection of data, analysis of that data. Tell me about some of the latest technological breakthroughs that are happening within your field.
Yeah, so I should, with respect to AI, I should also mention that any tool that humans developed in the past, was used by both bad actors and good actors, right? So it could be a blessing or a curse, depending on how you use it. And we should be, of course, watching out for bad actors, because AI, for example, can be used to manipulate people. And most recently, I witnessed that because in the last 2 months, there were some people that created fake AI-generated videos on a channel on YouTube that are speaking in my voice, looking like me. And I think it's a big problem for, because people cannot decide which content to believe. And I decided just yesterday to create my own YouTube channel where I provide the information the way it is. And I will take down those fake videos that are basically misinforming or misleading the public. So that's a potential risk. I also worry about the AI creating hate among people. It's because of an algorithm that somehow has commercial benefits, and we need to protect ourselves from that, especially young children. But as you say, the positive aspects of having this tool makes us much more powerful, and we can explore huge data sets and find things that previously were impossible for the human brain to find, because these tools are very quick, very fast. And so I do see it as a new frontier, as you just pointed out. And now the fundamental reason I am a scientist is I grew up on a farm, and I fell in love with nature. I still, every morning I jog at sunrise, and in the company of ducks, wild turkeys, birds. Nature is really beautiful, and I'm in love with nature. And the best way to express your love to anyone is by trying to know as much as possible about that subject, and that's the best expression of your love. You want to know not only the good things, also the bad, everything you can. And science is a way of learning about nature. It's a way of getting as much information as possible about the subject of my love. I was never planning to become a scientist. It was a matter of circumstances that brought me to that. I was interested in philosophy, and one thing led to another. I mean, I led the project, the first international project that was funded by President Reagan's Star Wars initially back in the mid-1980s. And that's what brought me to the US. And I ended up as a professor of astrophysics at Harvard University, something that I have never anticipated. But then I realized, even though it was an arranged marriage by circumstances, I'm actually married to my true love, because I can pursue fundamental questions about nature using the tools of science. And science is just a tool. It's misused by many people, because many people use it in order to promote themselves, to show that they are smart. When you do it this way, you are missing the point, and that's what you see in academia. A lot of people are basically trying to show off using the tools of. So you have a whole community that leads theoretical physics for 50 years, discussing ideas that were not testable are not tested and will not be tested probably in the coming decades. This is called string theory. They discuss extra dimensions. So I say they're missing the point. Of course, they are showing off their mathematical virtuosity, and they're very focused on showing how smart they are, but they're not studying nature. The way to study nature is to look at nature and to figure out whether the ideas that you have are correct or not, because we were wrong many times. And so that's my approach, basically using experimental data, the feedback that we get from observing nature, to learn about it. And in terms of my field of astrophysics, we learned so much. First, we know how the universe started. We know that it started from a hot, dense phase. And initially, it was like a soup of matter and radiation. There wasn't much structure in it. And regions that were slightly denser than average eventually condensed to make galaxies like the Milky Way, inside of which gas started condensing into the clouds and eventually collapsing to make stars like the sun, around which there was some debris left that made planets like the Earth. So we can understand in the context of the Big Bang where we came from. And you might say, okay, what happened before the Big Bang? That's a good question. That's the first question I want to ask an alien scientist, by the way, because it's our cosmic roots. We want to know what existed just before the Big Bang started. And we don't know. Why don't we know? Because our best theory that everyone is using is Albert Einstein's theory of gravity. And it breaks down if you go all the way back to the Big Bang when the density of matter was infinite. The theory cannot figure out what happened before that. And we know why, because it doesn't have quantum mechanics in it. At very high densities of matter and radiation, you have to use quantum mechanics. So we don't have a quantum theory of gravity. That's one of the unsolved problems in physics. If we had such a theory, we could have solved the equations going through the Big Bang and figuring out what preceded that in principle, unless this was the beginning of everything. But at least we would know. And at the moment, we have no idea. So if we suppose we knew what kind of ingredients you need to create the Big Bang, what conditions you needed to create, then we would have a recipe for creating a baby universe, in principle. And we have no idea at the moment. That's why I'm saying we should approach this subject with humility, and it would be nice to figure out a theory of quantum gravity that could help us. But finding our more accomplished siblings could potentially give us a clue about how to answer questions to which we don't have an answer. Another thing we found in astrophysics are those extreme regions of space and time where space is curved. And so, for example, if you take a lot of matter and condense it into a point, there is a region around that point where even light cannot escape from that region. And this is called a black hole. And it was a result of Einstein's theory of gravity that such things should exist, even though, again, Einstein, at least in the 1930s, thought maybe this kind of objects does not exist. But then we have found those objects. We have an image of the silhouette by now created by a black hole. This image was produced in the conference room of the Black Hole Initiative, for which I served as the founding director. It's amazing. These things exist. And if you ever fall into a black hole, you will never be able to escape. It's like the ultimate prison. And
so let me ask you something about this, because now you're getting into a subject that also has some interest to me with regards to CERN and things that they've been doing, experiments that they've been doing there. There was a lot of fear that when they turned on CERN, right, that they would be creating black holes and that they would fall to the center of the Earth and, destroy our own planet. What do we know now? And what have they been able to do in terms of experiments that have been helpful for astrophysics, for example?
Well, that's an excellent question, because the one thing we know about the universe is that 84% of the matter in the universe is of a substance that we don't know what it is. We call it dark matter because this matter doesn't interact with light. We cannot see it. The reason we know it exists is because there is more gravity than we can explain with visible matter. So we know there is more stuff out there, for example, in galaxies, but we can't see it. And the hope was that the Large Hadron Collider that CERN built would potentially produce, by smashing particles at very high energies, produce dark matter particles. And that collider cost about $10 billion. We haven't found those particles. And again, it shows you that sometimes we're hoping to find something and within the mainstream of science, and we are wrong. There was a new symmetry of nature that was supposed to reveal the dark matter. It's called supersymmetry. We didn't find it with the Large Hadron Collider. We did find another particle called the Higgs boson, which is responsible for what we already know about the standard model of particles. And the Nobel Prize was awarded for that confirmation. But this is an idea from the 1960s. The really new revelation that we were hoping for is finding dark matter, but we haven't. And so in that sense, it's work in progress. And it just shows that there is much more to do. And one of the things that I feel very rewarded in terms of recent months, one of the things that I was most pleased with is that I appeared on thousands of television interviews, podcast interviews, and I got emails from parents that tell me, because of you, our daughter or son, there was a U.S. Air Force pilot that wrote about his daughter, and he said, because of you, my daughter Ariana is now, she wants to become a scientist. She talks about aliens, and she's really fascinated by this subject. And to me, that's the biggest compliment that I can get, because maybe this young generation will solve the problems that my generation failed to solve. There are so many things we don't understand that we leave behind for the next generation to find out. If we understand what dark matter is, there is also an important component of the universe called dark energy. It's a form of energy that, again, we don't know what it's made of. And if we were to find out, perhaps we could use it for our technologies, it could explain what we don't see. So in a way, it's a known unknown. So in science, we usually fund research on things that we know that we don't know, like the dark matter. However, the most exciting revelations that we can have is the unknown unknowns. These are things that we don't even recognize that we don't know. And I'm very much looking forward to that. Now, the only way to find unknown unknowns is by taking a different path than most other people take, because this way you might discover something you didn't anticipate. If everyone is doing the same thing, first of all, it suppresses innovation. People don't think on their own, they don't think critically. But most importantly, you explore only one possibility. And if, like with a Large Hadron Collider, if you end up in a dead end, then the entire community, spent decades going in the wrong direction. So it's really important to diversify the portfolio, just like in financial investments, and take some risky paths that you don't know in advance whether you will discover what you're looking for, but at least you are trying more possibilities. And right now, for example, astronomers are focusing on looking for microbes. That's the ambition, to search for microbes. Because we know that microbes existed on Earth very soon after the Earth formed, within hundreds of millions of years. And so we say, well, they must be very abundant. But my point is, when you go on a date, you better aim high. You want to find someone smarter than you, not someone dumber than you, because that would allow you to grow. And so I'm saying, let's search also for intelligence out there, not just microbes. And right now, all the plans are to invest, $10 billion in the next space observatory called the Habitable World Observatory to look for microbes. And I say, why don't we look for industrial pollution in the atmospheres of exoplanets? Why don't we search for artificial lights? Why don't we search for packages that arrive to our mailbox? These are things we can look for.
That's an interesting. You just made me think of something. I can't remember what chemical it is, and even where it was found. Maybe on the moon or on Mars. But they found something. They found something that is man-made, or that it doesn't occur in nature.
Oh. Yeah, that's related to 3I Atlas, the object that we haven't spoken much about. Yeah. And that's the latest visitor to our backyard. It's really surprising, and I'm very curious about its nature, because it arrived it's moving in the same plane as the planets around the sun, to within 5 degrees. And the chance of that happening at random is 1 in 500. So why would the third object that we discovered from interstellar space be in that plane unless it was targeting the planets in the solar system? And it has other anomalies, things that do not quite fit what we know about the icebergs, from the solar system, like comets. For example, most recently, there were 20 images taken by the Hubble Space Telescope in the last 2 months. 20. And I analyzed them with a colleague of mine, and this object shows glow. There is a glowing halo around it. But when you remove that glowing halo that is spherically symmetric, circular around it, you end up with 3 mini jets that are coming from the nucleus of the object, and they're equally separated from each other by 120 degrees on the sky. And that's very surprising. And the immediate question is, are these technological signatures? Are these thrusters? And then you see also a much more prominent jet in the direction of the sun. Usually what we see is a glow around comets extended in the opposite direction.
Right. Yeah.
This is an anti-tail. Usually we see a tail. And the question is why and how is this anti-tail produced? It goes out to a distance comparable to the Earth-Moon separation. It's a huge anti-tail. And so there are a number of anomalies. But the one that you mentioned is that in the plume of gas around this object, we found a lot of nickel with almost no iron. And in nature, in all the astrophysical objects that we ever explored, usually nickel and iron come in comparable amounts because they're both produced by exploding stars. So when we find nickel, for example, for the impact of an asteroid on Earth, there is also iron there. You don't just find nickel on its own. And here we identify from a distance nickel with very little iron. And the only other place where we find it is in industrial production of nickel alloys. And so the observers that discovered the nickel with no iron, they said, well, maybe nature operates the same way that our industries do. And there is this carbonyl chemical pathway to produce, to remove the iron out of it. But we've never seen it in nature. So again, a possible technological signature. It may well be, and that's my argument since the beginning, that it's most likely a natural comet, just like everyone suspects. But we need to understand those anomalies in order to be absolutely sure.
So that the one about the jet that is, basically an anti-tail, right? It's towards the sun. If you were just using a thought experiment, if you were to say, okay, let's say that this was a non-natural, craft of some sort, what would be the purpose of a jet towards the sun? Wouldn't it be to kind of help escape the gravity of the sun, or?
No, it would be potentially to protect the technological object against, flares on the sun, the solar wind. So the sun is also creating a wind that it goes out at a very high speed of order 500 kilometers per second. You know, that is a huge speed that is about 10,000 times faster than our fastest cars, you know. And when something like that impacts a technological object, especially when you come close to the sun, it could be damaging. So one way to deflect the solar wind is by sending out a beam of particles or light that affects the solar wind. And it could also be that there is dust in that anti-tail that also blocks sunlight from harming whatever is inside. So that could be one reason for it, and that's why it's always pointed at the sun. You know, that's one possibility. But in addition, you want to stabilize any spacecraft, and for that you need some thrusters, and a configuration of 3 mini jets could stabilize it in 2 dimensions, and then the object is also rotating along the 3rd axis, perpendicular to that. And by the way, the rotation axis is also pointing at the sun, another anomaly of this object. But it might also be just a rare chance that there are pockets of ice on the surface of a rock that happen to be vaporized by sunlight, and that's what you see in comets. And it's just by chance that they happen to be oriented in this way, and also that this object by chance arrived into the solar system along the plane of the planets. So all these coincidences could be chance coincidences. It will pass close to Jupiter, and by close I mean it will arrive exactly at the distance where Jupiter's gravity dominates over the sun's gravity on March 16th, 2026 this year. And just to give you a sense of how fast it is, it was passing near 2 spacecraft created by the European Space Agency. One is called JUICE and the other one is Europa Clipper. They are heading towards Jupiter. It will get to Jupiter in March this year, whereas this spacecraft will get to Jupiter in 2030, 2031. So it's so fast. But near Jupiter, there is actually a spacecraft called Juno. It's already there. And I suggested using it to observe if 3i Atlas releases any probes, mini probes that will become satellites of Jupiter. And in fact, I had a conversation with Representative Anna Paulina Luna, who called me on the phone, and we spoke about 3i Atlas back in July, and she was very curious about it, and I very much appreciate her help and support, because she wrote a letter to NASA encouraging them to use Juno. And also in general, we talk about unidentified anomalous phenomena, and I very much salute her and Tim Burchett as well, who are engaged in trying to figure out what these objects are and whether they might be extraterrestrial in origin.
Yeah, that brings up a good point. Or is there any way that, like currently the pictures that we have, right, of 3i Atlas are kind of grainy. There's nothing that is really like a clear picture, right?
Yes.
Is there a possibility of getting much better pictures as this thing gets closer?
Yeah, well, in principle, if Juno, for example, that was what I told the Representative Luna, if Juno had all the fuel that they started the spacecraft with, it could have maneuvered to actually intercept 3i Atlas, potentially collide with it, and get a close-up photograph of it. But unfortunately, it turns out that they used 90%, more than 90% of the fuel that they started with on that mission, because it's more than a decade old. And so they can't do that. But in the future, what we want is a potential interceptor, that will come close to an interstellar object, give us a close-up photograph. Then we can easily tell if it's a rock or maybe it has buttons on it. If it has buttons on it, the question would be, should we press a button?
Yeah, that's always that's always a good question. I'm wondering, with your background, speaking of interception, right? You just made me think of something, so I'm going to kind of bird trail off a little bit off topic, and we'll come back to it. But you worked on the SDI project,
right?
Trump has just made a deal.
Yes, Golden Dome.
Yeah, to be able to get sovereignty over certain portions of Greenland. At least this is what's being being talked about.
Right.
The idea is it's critically important for the Golden Dome.
Right.
With your background and knowledge, what can you tell us about that? What does that look like, and how important does astrophysics play into even that kind of critical defense system?
Well, that's extremely important, and I should say that when I started my career in the context of the Strategic Defense Initiative of President Reagan, a lot of people in academia ridiculed the idea. I mean, of intercepting ballistic missiles. They thought it's not practical; it will never happen. And just look at what happened when the Iranians launched so many of them and that were intercepted. It's extremely important. It's for national security. I really salute President Trump for establishing a Golden Dome. I think it's very important for the safety of our nation. And we can definitely do it. And the reason we can do it is we understand physics quite well. And right now we have technologies that allow us to realize and mitigate the risk from ballistic missiles that we know adversarial nations have. And North Korea is a potential threat, in addition, of course, to Russia and Iran and other bad actors. And in that context, for example, GPS systems, just to give they're essential for navigating in space and also for mitigating the risk from space. And they would never operate without Einstein's theory of gravity. If we didn't understand gravity so well, we would never reach the precision that gladly we do understand it very well. There are many physical effects that we need to understand in order to be superior to our competitors around the globe. And that's why physics is important. Obviously everyone knows about the Manhattan Project that had a huge influence on the end of the Second World War. And, the Nazi regime was an example of bad actors. But we obviously face threats that are no lesser right now. And we want to have the best technologies to mitigate the potential risk, because these ballistic missiles are really quite dangerous. If you knew how dangerous they are, you might lose a lot of sleep, actually. And so in this context, getting access to Greenland is very important. It's a huge piece of land in a very strategic location, but also developing the technologies that would benefit national security is a very high priority. And just as I thought it was back in the 1980s, it's even more right now. And knowing physics is definitely very useful for that. And I do believe that, as citizens, we have an obligation to help our government accomplish its goals and to protect the nation. And we need to be always ahead of our competitors. And the way to be ahead of them is to have the best science and technology that the world has to offer. And it doesn't just include AI. Of course, everyone now is talking about AI, but I believe in natural intelligence, allowing the US to be superior. Natural intelligence is even more important than artificial intelligence. And my hope is that we will remain superior. And just look at what happened in Venezuela or in Iran a year ago. And it's clear that, when the B-2 bombers were flying overhead above the Iranian air defense system, it didn't know what to do about it. And it's just thanks to this. And we can save a lot of lives in operations like that.
I wonder if people realize that operation in Iran is literally the equivalent of the movie Star Wars, where they're flying. He's got to drop a bomb down a ventilation shaft. That is what they did. We are living in sci-fi. I mean, it's just crazy.
Well, President Reagan did call the program Star Wars, right?
Yeah.
So yeah, you are exactly right. And it's interesting. I'm an astrophysicist. I deal with the stars, but I started my career in this context. And I'm not just a scientist thinking abstractly. I also realize there are challenges here on Earth that we need to address for our safety. And in that context, the better minds that we have will help us to develop the best technologies and science that nobody else has, and maintain our superiority, and make sure that the things that we believe in, the guiding principles of the American nation, are really ruling the day. Because if bad actors, if Nazi Germany were to win, the world would be very different. History is always told by whoever wins. And it's really important that we tell the history.
Well, this is something that Trump talked about at Davos. It is so critically important that we have peace in the world in order for us to be able to use our money on advancing, our and progressing in the areas of science and health and
Right.
all of these other things. Because the fact is that, like, I don't think people realize just how much a war, a prolonged, protracted war, does to actually slow us down and stop us, from just a major advancements that we could have done.
Yeah. I mean,
The
there are
amount of money that goes into it.
there are two aspects to it. One, it consumes resources. Okay, so we are, instead of using the same resource, the same money to do something positive, we are wasting it on protecting ourselves against others that want to kill us. But there is another aspect, and that is, it creates a conflict. Creates a situation where we don't cooperate with other nations, and so in principle, it's not, it's not the sum. I mean, humanity is not just the sum of the parts. When you have collaboration, partnership, you end up with much more than the sum of the parts.
And without a doubt, a perfect example of that is, why is the United States been so successful, and for such a young nation to have become so powerful? And it is, without a doubt, it is the union of all of these states. If we were balkanized and completely separated, we would have been fighting, wars nonstop against each other. And that would have, prevented us from being able to move forward, and dominate really this side of the hemisphere.
Yeah, and it's not just that. Everyone wants to come to the US, and it's obviously, it was a very successful endeavor, and we need to maintain its success, and that will be done through partnerships. And as of now, of course, there are bad actors, and we need to fight them. But if we show strength, then they would eventually decide that it's in their best interest to work with us. And that is, the best approach. But to be in that position, we really need to be superior in terms of our technologies, in terms of our science.
In the area of astrophysics, right now, what other nation is really, I would say, like, kind of our biggest partner in those types of joint ventures?
I would say the Europeans. There is a European conglomerate of countries that develop telescopes that are, for example, in Chile, some of them, and also in Hawaii, and also in space. The European Space Agency is launching missions, and we have a partnership with them. NASA has a partnership with ESA, and for example, just to give an example, within the coming decade, the plan is to launch a mission that will basically observe the universe in a completely different way than we currently observe. I mean, until 2015, we observed only light from the universe, and that's the method that Galileo started about 400 years ago. But in 2015, for the first time, we detected ripples in space and time that are generated when two black holes come together at the edge of the universe. So, just like moving sticks on the surface of a pond, you generate waves. And so if you have two black holes, I mean, in Einstein's gravity, gravity is basically the curvature of space and time. So an object
How
like,
would you detect a wave without light? I mean, I'm
yeah.
just curious. Like, so how do you guys do that?
So here is the idea. You can think of space and time like the surface of a trampoline. That is a rubber surface,
Sure.
right? So if you put something heavy like a bowling ball at the center of a trampoline, it makes the surface curved, right? So then if you have a marble that moves just at the right speed around that bowling ball that curves the surface, the marble may actually go in a circle around the center because the surface is curved. If you were to remove the bowling ball from the trampoline and it will become flat again, then the marble will move in a straight line. Okay, and that is, if you can think the same way about the Earth moving around the sun. The Earth moves around the sun because the sun is that bowling ball. It curves space and time in a way that makes the Earth move in a circle around the sun instead of moving. If you were to remove the sun from the solar system, then the Earth would move in a straight line. Okay, so gravity.
What is at the center of a pinwheel galaxy? Then is it like a large?
There is a giant black hole, and there is a lot of other. There are stars. There is gas. There is dark matter. So all these ingredients fill up space and in a galaxy. So anyway, now imagine taking one bowling ball and putting another one, and they move around each other. Okay. That creates waves, ripples in that rubber surface of the trampoline. And so that it's just like moving sticks on the surface of a pond. You generate waves. And so that's what we can detect. How do we detect it? Because these waves eventually from the edge of the universe, they reach us and they shake a little bit space and time. So if you were to measure space-time very precisely with lasers, and that's what we do in the LIGO experiment, for example, that was funded by the National Science Foundation. So then we can discover events like the merger of two black holes that collided at the edge of the universe. And in fact, the LIGO experiment that was funded by the NSF was the first one to discover such waves, and they got the Nobel Prize for it. So that's an amazing discovery, that now we can observe the universe through gravitational waves. That's the name of these waves. And then the next mission is actually to put lasers in space. And then you can detect very massive black holes coming together. So, our own galaxy is on a collision course with its neighbor. There is a sister galaxy called the Andromeda. You can see it from in the sky from some parts of the world. And the Andromeda galaxy is about to collide with the Milky Way galaxy. We shouldn't lose much sleep. It will take a few billion years for that collision. But then the two black holes that both galaxies have at their center, they will come together and merge. And at that point, when two supermassive black holes that carry about 1 million or 10 million times the mass of the sun, when two such supermassive black holes come together, they generate also ripples of space-time, but at a very low frequency. And this space interferometer, this space observatory called LISA, is the one to detect those collisions of very massive black holes at the edge of the universe, all the way through the universe. And this is a collaboration between the European Space Agency and NASA, just to give an example. So the Europeans are partners on many things. They're also competitors with the US. And obviously, the best science is still being done here in the US.
So let me ask you something else. This is just kind of my brain's curiosity. When we look at matter that is in our visible, world, right? We have a periodic table of elements. Is there any kind of thought on whether dark matter might have its own set of periodic elements, if you will?
That's actually a very deep insight that you had, because the question is, what is dark matter? Mm-hmm. And one possibility is that there is a sector of matter, just like the one that we are made of. And as you said, we are made of elements from the periodic table. So maybe there is another periodic table of matter that does not interact with light, but has a lot of different types of particles, different elements in it. So it's possible that dark matter might be a mixed bag that has a lot of different particles in it. They might be particles not very different from the ordinary matter, but we haven't found them yet. Okay, so we are doing a lot of experiments, like as I mentioned before, CERN did some, but there are plenty of experiments. Billions of dollars were invested in the search for dark matter for decades. We haven't found it yet. It's one of the unsolved mysteries.
If we did find it, and we were able to unlock these things, I'm assuming that there probably is some sort of one of the things I've always wanted to know about, and I've never quite understood, no matter how many times people try to explain it to me, it just doesn't make sense, is I get the whole concept of gravity in terms of what you were talking about with the
Curvature of space-time. Yeah.
Curvature of space-time. I get that. But what about the ability to create like artificial gravity? That is something that's always, or to defy, natural gravity.
Yeah, that's the next
anti-gravity. Those are things that I'm kind of like, if there was anything that we could discover, in this realm of the unknown, that's what I want to know.
Yeah, that's a fascinating question, and let me just give you an application. So right now we have Starship as our flagship rocket that Elon Musk is developing. Starship is about 120 meters in height, comparable to the size of a football field.
Mm-hmm.
But that includes the booster. Most of it is the booster. The payload is tiny, like less a few percent in size, and most of it is the fuel. And the reason we need this fuel to lift off a payload out of the gravity of the Earth is because gravity is attractive. So this payload is being attracted to the center of Earth by gravity, and we need to compensate for that by the rocket fuel that pushes the payload away from the Earth's gravity. And now, just think, suppose we had we had the technology to create a negative mass. The payload is a positive mass. All the masses that we know about are positive; they attract gravitationally. But suppose we had the technology to create a negative mass, meaning that it creates repulsive gravity rather than attractive gravity. In electromagnetism, you have positive and negative charges, right? So you can imagine maybe there is a way of creating a negative mass. We haven't found it yet. If we had a negative, then you just need to attach to the payload a negative mass of equal magnitude, and then the total mass would be zero. So that means this object with a positive mass payload and the negative mass attached to it has no mass. So it's not confined to the Earth by gravity. It's just like a balloon that has helium in it. You just give it a small nudge and it escapes from the Earth's gravity. You don't need this huge fuel reservoir of Starship. Mm-hmm. So we are working really hard to lift payloads out of the gravity of the Earth. If we had access to a technology that generates anti-gravity or some negative mass, it would be a piece of cake to lift things up. So you might say, okay, well, maybe someone managed to do that. That's why we should observe the sky to figure out if there are.
Let's talk about that for a minute. There's been experiments on a small scale, right, using superconductors and cooling them down to like super cold levels, and they float. They basically they have anti-gravity properties. What if they made a spacecraft out of this stuff? I mean, on Earth, it's going to be warm, but when you get in space, it's cold. So would it, in fact, I wonder what it would do. I mean,
So we do have examples where anti-gravity is sort of observed in principle, but you have to realize that in all of those examples, like we created technologically, in all of them, the setup is weighing much more than the small, part of the experiment that shows sort of negative gravity. So we were never able to use that for any propulsion system, or it's still, something we don't fully understand.
How is it that liquid nitrogen, though, it seems to change, I guess, the gravitation of these? Like, how is that interaction happening?
I mean, what we know is the standard way to make rockets. So you have some fuel reservoir, and the best rocket might be hydrogen actually, and the best rocket fuel. But basically, you burn it up and you throw some gas out of an exhaust, and that's giving a recoil to the payload in the opposite direction. So that's the way rockets operate. That's the way jet planes operate. We basically throw something backwards, just like an ice skater that
Right.
throws something backwards and then it moves forward. But there might be a better way. And now one thing I should have mentioned is the universe is not just expanding. Over the past few decades, we discovered that the expansion is accelerating right now. So that means there is some sense of anti-gravity operating on the cosmic scales. And we currently think of it as being triggered by this dark energy that I mentioned to you. If we were able to bottle dark energy in a way that allows us to make a negative mass object, then we would have a device with anti-gravity. But so far, we don't know what the dark energy is. Remember, that's one of the unknowns about the universe. And potentially, as I said, we could, if we understood it, we could use it for our technologies.
So there's a lot of discussions amongst those that have studied the UFO phenomenon, that they're using some sort of anti-gravity engine of some sort, or that they are projecting some sort of bubble around them, that makes it so that they have no friction with anything. Because and this is to me one of the more I don't like getting into things that there's no solid evidence, but I think there's plenty of evidence that that's observable of these objects moving in ways that the inertia, if it's moving so fast that it would kill any occupant, if they don't have something that is countering that inertia. And
right.
So to me, this is just one of those areas where, to me, it would make sense to look at and try to observe more of this kind of stuff, because I think we're clearly, whatever it is that created these things, whether they are probes, whether they are alien craft, I don't know, but they clearly are maneuvering in ways that defy our own physics.
I completely agree. I was not privileged enough to see, the classified data that perhaps the U.S. government has. But there are people who report that there is such information, but I haven't seen it. I haven't witnessed it. And that's part of the mission that the representatives Anna Paulina Luna and Tim Burchett are pursuing. I wish them the best. I really hope, I'm just curious if these things are out there, and if the government were to ask me to help them figure it out, I would love to do it. For me, it's just, it's not a matter of broadcasting the information, because it could have implications for the financial markets, for the kind of unrest
security,
that will create. But for me, it's just a matter of curiosity. I really want to know whether there is someone out there, and the government would be the first one to notice something unusual, because it monitors the sky all the time for national security purposes. Astronomers are focusing on very distant sources of light and that have no implications to our life most of the time. And so it's quite possible that the US government will be the first to discover something amazing. And I would love to help them figure it out if they have such data.
So if you were to propose, let's say that we get these sections of, the northern part of Greenland, so we can set up our Golden Dome. And let's say that there was theoretically they wanted to offer up to the scientific community in America, what kinds of experiments would you propose to be done within the Arctic Circle for astrophysics?
I have to think about it, but the South Pole is currently being used by the National Science Foundation for scientific work. Just to give you an example, there is one experiment done there, which is a flagship experiment, looking for the gravitational waves, those ripples of space-time from the Big Bang, from the beginning, that could give us a new way of looking at the universe, because the universe was opaque when it started. It was too dense for us to look through it in light. So we can only see everything that happened all the way back to when the universe was 400,000 years old. Earlier than that, the universe was opaque. The light is unable to arrive at us from earlier times when we look far away. But on the other hand, if we detect gravitational waves, we can go all the way to the beginning. And so that one of these experiments aiming to discover gravitational waves from the Big Bang is funded by the National Science Foundation. It's located in the South Pole, and one of my colleagues works on that. So in terms of having access to Greenland, there are lots of possibilities. We can look for dark matter in a completely new way. There is a way to detect exotic particles using the ice. We can detect also the most energetic particles in the universe. When they pass through ice, they create a shower of particles that we can detect. And that will teach us about the engines that make the most energetic particles in the universe. These are sort of like particle colliders that we don't need to invest money in building, because nature produced those accelerators, and we can just detect those particles. There are many ways. I would also think about reaching basically observing the sky in a much better way than anywhere else, because the atmosphere doesn't have much water vapor over there. And but in addition, of course, one should think about defense-related technologies that can be put there. And I'll be glad to serve on a panel that looks into all possibilities and makes strategic decisions about how to use it. It will be extremely useful for both the defense sector and for science.
Wow. Well, this has been a very fascinating conversation. I could probably go on for hours just asking questions, but I'm really excited about the future and where things are headed. I feel like I actually feel hopeful. That there are some opportunities that we have to solve some really big problems.
The way I say it usually is, the best is yet to come.
Yes, and I agree.
And it's really important to be an optimist in life, because sometimes life is a self-fulfilling prophecy.
Yeah. When you think about your field over the last, couple of decades, what discoveries have just completely rewritten, astrophysics as we knew it?
Yeah. So one is the fact that the universe is accelerating. And why is that changing the way we perceive the universe? Because anything we see far away from us is moving away from us right now. Like all these other galaxies, like the Milky Way, far away from us, they're receding from us due to the expansion of the universe. But they are moving faster and faster as time goes on. So eventually they'll reach the speed of light. We won't be able to see them anymore after that time. And it would mean that in the distant future, that there is this question of what will happen tens of billions of years from now. We might be left in the darkness without all these galaxies visible to us. So that's really a big change in the way we think about the universe, if the cosmic acceleration will continue. So that's
based on that acceleration. When you think back to the earliest written records that we have of man, and of course I think of the Bible as, I think about Abraham and Noah and these guys. What did the sky look like back then?
Oh, it was much easier to watch the sky. You didn't have light pollution. Right now, we are, the privilege of seeing the cosmos is taken away from us in cities. And I visited Tasmania, which is not as developed, as many other regions on Earth. And also, whenever you go to an observatory in a mountaintop, like in Hawaii, Mauna Kea. It's just an amazing view to look at the sky and see how many stars are out there. It gives you a sense of cosmic modesty that I was really advocating before, but we forget about that when we are surrounded by city lights. And so, that now another important discovery of the past few decades is exoplanets. These are planets around other stars. Before that, when I started astrophysics, it was thought that maybe the solar system is unique and special. Now we know that about 10% of all sun-like stars may have a planet like the Earth. After we found so many planets, around more than 5,000 stars, and we know that it's quite ubiquitous. Then, of course, the question is, do they have residents just like us or even more accomplished than us? And
this goes back to your first question of we need to be looking at those planets for signs of industrialization and pollution, because that would probably be the clearest sign that there's something there.
If you live on a planet that is a little too far from the host star, it's actually freezing on that planet. So you might actually want to pollute the atmosphere in order to put a blanket that protects you against the cold. So it could actually be a good thing to have industrial pollution on a planet that is a bit, too far from the host star. And we always think of it maybe as a negative thing because we think of currently the Earth as paradise. But it's not always. There are so many different conditions on other planets, that it just broadens our perspective to think about them. And then another, major discovery is the way, of observing the universe with gravitational waves. That's a complete, we are observing basically dark objects like black holes colliding, not producing any light. Because a black hole is, as I said before, it's like the best version of Las Vegas. Whatever happens there stays there. So a black hole is just black. And then when two such things collide in the darkness, the only way to see them is through gravitational waves. And that's the method developed by LIGO that was funded by the National Science Foundation. So this is another major discovery of observing the universe in a different way. But I think the biggest discovery that will change the future of humanity would be to recognize another intelligent species out there. And, we can learn from them. It would be an inspiration for us if they're more advanced than we are. They could serve as role models, like Oscar Wilde said, imitation is the sincerest form of flattery. Mm-hmm. If we see them, if we realize that they built a space platform that accommodates them along, in long journeys in interstellar space, we might want to build our own space platform, not in order to go to Mars, but in order to go to the stars. What could be better than that?
I think this is something I've heard Elon Musk talk about, and I think he's right in this regard, that we have to get off of our planet and colonize somewhere, because all of the brilliance that the human race has created, one extinction level event,
right.
We're one extinction level event away from wiping out our existence. And if we had another colony on, say, Mars, and let's say something, God forbid, catastrophically happened to the Earth, at least we'd have a chance at continuing on.
In my book Interstellar, I have a chapter about Noah's spaceship. So we all know about Noah's Ark that was built in order to save animals against the Great Flood at the time. And you can think about the same concept of saving humanity from some catastrophe on Earth by building a spacecraft. Now, we can move to Mars. That's indeed one possibility. But we can also, just like we now live in high rises in cities, you can imagine us living in space. Mm-hmm. As of now, that imagination was restricted to Hollywood script writers. But I think the future could be even better than they imagined, where we will build a space platform that can accommodate humans. And then you can equip it with everything you need. You don't need just to go to a rock like Mars that nature provided us with, which is actually a desert. It's not. You can actually build a space habitat that accommodates humans, gives them everything you need. And for that, we need to decide about this being a priority, because right now, we're spending trillions of dollars every year on military budgets worldwide. And if we decide that space is a priority, I think we can reach very high. And one way for us to be convinced that this is feasible is to observe someone else, a neighbor that did that already.
So if you were to, we were talking a little bit earlier about light pollution and the problems, with being able to see things because of, and how different it is now than it was back, 20,000 years ago or whatever. Have you ever been to, there are some there's what is this program called? The super dark places. And there's dark sky places program. Mm-hmm. So the International Dark Sky Places program, one of those places is Watauga State Park in my state of West Virginia. So if you ever want to come down here to West Virginia, go check that out.
I'll be delighted. But you have to keep in mind that now we have maybe almost 10,000 communication satellites operating, many of which are Starlink. And think of them just like mirrors in the sky, like city lights in the sky, because when they are high enough, they basically reflect sunlight, even at during nighttime. And so, for example, the Rubin Observatory in Chile has to take out those tracks. You see them appearing along streaks in the sky when we take exposure. So even though the Rubin Observatory was put in a very good place in Chile, where the sky is very dark, nevertheless, there are these city lights in the sky. You escape from city lights on Earth and you find them in the sky because of the communication satellites. And that, in a way, is the one thing we can avoid by putting a telescope on the moon. So on the moon, as of now, there is not much traffic of satellites.
Human-made satellites. Even be powered by a helium-3 power plant.
Yeah, well, you don't need much. Yeah, you don't need much power for an observatory like a big telescope, and there is no atmosphere to the moon. So we have to struggle when we look at the stars or galaxies far away, because the atmosphere is distorting the image of those objects. And if we were to put a telescope on the moon, then of course there is no such concern. So, and by the way, in that regard, the Greenland is also a very good place, because it's basically so cold out there that no water vapor, not much water vapor out in, above you when you observe the sky.
Wow. Yeah. But although you have the things like the Northern Lights and stuff, which do cost some.
Oh, but those are beautiful, but they happen every now and then. So, and the other thing to keep in mind is that darkness lasts for months during the right time. If you go all the way to so it's as if you are blessed with a dark sky where you can observe the rest of the universe. It's just if the Earth was rotating, if the rotation axis was pointed at the sun, like it is in the case of 3i Atlas, there would have been a permanent night side to half of the Earth. Half of the Earth would be always in the dark, half of the Earth would be always in the day, in light, the sunlight. And the reason that we see day and night every 24 hours is simply because the rotation axis is, it's nearly perpendicular to the direction to the sun. So we change between day and night. But there could be other planets where there is a permanent day side and permanent night side. In fact, we know that near small stars, dwarf stars, when you have a habitable planet very close to those stars because they are dim, in the habitable zone, very often the planets are locked by tides. They are locked facing the star with one side all the time. So they have a permanent day side and permanent night side. That's the case in the nearest exoplanet around the Proxima Centauri. There is a planet in the habitable zone that it probably has a permanent day side and a permanent night side. So, what we find here on Earth, it can come in great variations on other planets.
Yeah. Well, I want to wrap things up. I think this has been a great discussion. And again, I hope that as more discoveries happen, especially if they do get some interesting data off of 3i Atlas as it approaches Jupiter, I hope you'll come back and share that with us.
I'll be delighted. Life is a learning experience, and I really wake up every morning, and when I go through my email, I feel that I learn something new, and through my work, during the day as well, and that's what makes life fun. That we can hope to make the world better by learning more about it, but by also improving ourselves. And
I want to end on a philosophical note, since that's kind of how you got your start. When you think about dark matter, and we have these dimensions, within our humanness, right? Consciousness that seems to be able to exist outside of the body. There's a lot of evidence of people having these experiences of out of body experiences, well documented. And I've often wondered, does something like maybe the soul exist in this dark matter area, right? What are your thoughts on that?
Well, it's possible. I'm a practical person, so I can think of a very good experiment that we can do to check it. We have now artificial intelligence systems. These are systems of just like the human brain, the sort of connections, neurons. In principle, as of now, these AI systems do not have as many connections, as many parameters as the human brain, but we might get there within the coming decade, and we might actually exceed the number of neurons. So if our brain, what we define as ourselves, is just a matter of the physical existence, that our brain contains neural connections, and that's the way we perceive reality, that's the way we develop consciousness. Everything is related to the physical existence of the brain. If that's the only thing that is out there, we should be able to reproduce it with AI systems, neural networks that we created. They are our own technological kids, so to speak. So if we create an AI system that has more connections, more parameters than the human brain, and we can ask it, do you have an out-of-body experience? Do you have a sense of, we can see if it behaves in the same way that we behave. And when you sort of interact with it, whether it has the same range of experiences as humans have. If the answer is yes, that those very advanced AI systems that we are creating and that we will have within a decade, you don't need to be very patient. Just wait a few years, we might get there. If those report back the same experiences that humans do in terms of consciousness, they display the same experiences as humans display, then I would say it's only physical, okay? Because we created something physical. I mean, computers have nothing else, which put together, ingredients, just like Lego pieces that are all physical things. And if it reproduces, when we make the machine complex enough, if it displays what humans do, then I would say we are also machines. We are just physical bodies. But if they don't, then we know there might be something else. So
my prediction is that we won't find that with AI.
Okay.
Only
Okay.
the same reason that the Hadron, the CERN and those things have not actually found. I think there's some things that are just beyond our ability to measure.
Well, that as I said, we should stay humble because we just don't know how much we don't know.
That is true.
So that's what makes life fun. That It's a learning experience, and we grow as we learn. As I said, the best is yet to come. We will be able to do the experiment and answer your question, hopefully within the coming decade. Let's just wait and see.
Yep. Well, I always like to ask my guest, we talked about all kinds of things tonight, but what do you want people to take away from our conversation? I think I already know the answer because you've been talking, you just were talking about it, but what do you want people to take away most from this conversation?
People that know me would testify that I haven't changed much since I was a child, a kid. I was very curious back then, and I decided not to be influenced too much by other people. So I don't care how many likes I get on. So I don't have any social media footprint.
Oh, good for you.
I actually was on Joe Rogan's podcast, and he said, "Thank God for that." And I said, "Don't thank God, thank my wife," because she basically made the case that I shouldn't have any social media footprint. And in a way, it maintains. There is a lot of junk intellectual food online. And I see it just like junk food that we could eat. That basically destroys our body health. And for the same reason, consuming junk intellectual food on social media can destroy your brain. So it's better not to consume it. And this way you stay healthy. But my main advice is stay true to your childhood curiosity, because very often we are trapped in situations where we want to be the adults in the room. In other words, we dismiss what we don't know. We show off as if we know everything and we are in control. But the reality of the situation is that in life, very often, you are not in control. You don't know. There is a lot of uncertainty, a lot of unknown. And if we only approach it with the same sense of curiosity and awe that kids do, I think we would be happier. Because it's not about us. It's not about our ego.
That's so true.
It's about learning how much we don't know.
Yeah. No, I think that's a great way to end the show tonight. And I always close out my show in prayer, and I'm going to do that now. But I really thank you for just what an awesome discussion tonight. And I think this has been one of the most enjoyable, shows to get into these types of deep subjects. And you taught me something, and reminded me of the importance of humility, even in our understanding of what might be coming, if we were to have some sort of visitation or whatever.
Well, thanks for having me. And I also wanted to say thank you, because I learned from you as well. Any dialogue is a learning for both sides.
Absolutely. Well, Heavenly Father, I thank you for this opportunity to learn. And I pray that you would help us all to humble ourselves so that we don't have to be humbled by your hand. And we just pray, God, that you would open our eyes. And as we advance, that you would show us things about your creation and help us to have a better understanding of the world that we live in and the universe that we sit within. We ask all this in Jesus' name, amen. All right. Well, thank you so much. And folks, I want to thank you guys for joining tonight. As you heard, Dr. Loeb does not have social media, but I'm sure you probably have a website or somewhere where people can, get information about the research that you're doing.
Well, I have daily essays on medium.com. So just search for AVI, my first name, Avi, dash LOEB, that's my last name, .medium.com. And as of yesterday, I decided to have also presence on YouTube, just to fight those fake AI videos created by bad actors.
Yeah.
And you could find me there as well. There would be also a Netflix documentary coming out in 2026 about my research. And part of it that we didn't have time to get to involved an expedition to the Pacific Ocean. So you will see that featured in the Netflix documentary. And there is a book that I just finished writing, but it will come out probably within a year with MIT Press about that expedition. So a lot is yet to come, and it should be an exciting year.
Awesome. Well, when your book comes out, I hope you'll shoot me an email, let me know, because I definitely would love to read it.
I'll be delighted. We didn't discuss it at all, the expedition, so we can do it next time.
Yeah, absolutely. Well, thank you, Dr. Loeb, and everybody. Thank you guys again for joining the show tonight. Make sure and like and subscribe, and please share it with everybody that you know that has a scientific mind and that wants to learn new things. This is one of those great shows for learning. And again, I want to thank you and thank our guest for coming on tonight. With that, have a great rest of your week and enjoy the snow. Stay warm.
Raise some cane. You gotta raise some cane. In the heartland where the faith runs strong, we've seen the shadows growing long. Watch those around us be deceived. Yeah, the fight is at our doors, no matter who we believe. Corruption, lawless day and night, we'll speak the truth into the light. We'll bring the battle, heed the call, watch the whole thing fall. We gotta raise some Cain, show the lies, break some chains and make things right. Feel the power, be the change, time is now. We gotta raise some Cain.